Yep, it's up front.
How about that? Awesome. All right. Well, again, my name is Christian Garrett. I'm a maintenance trainer here with Garmin Aviation Training. And just over to my side, I do have a new colleague whose name is Jason. I don't think you guys are going to see Jason, unfortunately, today. Looks like the webcam is just focused in on yours truly. But we've got quite a bit of material to cover. And without further ado, let's go ahead and march through. All right. As I said, my name is Christian Garrett. I'm a Kansas City native. I was born and raised here. And a fun fact about myself is my parents met years ago while on the city bus. My dad was a community college student. Fast forward from that moment, yours truly joined the U.S. Air Force, and I served 8 years active duty as an avionics technician on most varieties of the F-15. And during that time, another fun fact is I served 4 years in Elmendorf Air Force Base. So I was up in Alaska in the Anchorage area, probably just a little ways away from where you guys are housed right now, having your Alaska Air Carriers convention. And during that time, I remember very favorably experiencing Northern Lights during winter exercise, Ship Creek, watching salmon runs, being with my friends and doing fun things in June, like, hey, let's go ahead and see it at 9 o'clock if we can make it down to Seward and hike Mount Marathon before it gets too dark. So being in Alaska, that was very fun, and it's a very unexpected pleasure to be providing training for folks in what was my old homeland that I still miss to this day. Before we go any forward, we do have our email address from Garmin Aviation Training on the screen. If you have any questions that may come up to you either during this webinar and even thereafter, this is a good email address from which to contact us. Also, if you have training questions, say you want training, how can you attend some of our training here? How can you connect with us when we're doing training out in the field? This is also another good email link to pose such questions. Without going any further, legally, I want to say, please do not sign off your return to service in accordance with this humble person's PowerPoint presentation. Do go ahead and follow the legal disclaimer that I have on screen. Garmin Aviation Training is intended to provide the best practices for installation, use, and maintenance of Garmin aviation products. It's incumbent upon technicians and pilots to ensure that the instructions contained in the most recent versions of Garmin products and manuals, bulletins, and notifications are followed. Here, what you may see is something a bit curious. This is the Slido link, a QR code. And what this is going to do, this is our attempt to ensure that your PowerPoint presentation is a little bit more interactive than probably what you're used to. It's a bit of an undertaking to sit still and have a lot of information wash over you. So we've actually created an interactive interface. This is our way of providing handouts to you, providing helpful links, and giving you a chance to pose questions to us during the webinar, and also for us to pose questions back to you. So I'm going to leave this QR code up just for a second longer, but not to worry if you don't get it before I click, because every time I have an interactive, this QR code will also show up on screen. And just another something about Slido, it will ask for your name and your email, but don't be concerned about that. I'm not trying to gather your information so that I can then send it over to our marketing people and try to hold you guys hostage for a sale. Nothing like that is going to be taking place. Basically, just want your name and email just for the purpose of doing this Slido interactive. Once the event is done, we go in and kill and limit, that is, the names and emails, contacts interactive, and this information does not get handed off to anyone else. That being said, scan the QR code that was on the screen, and that'll direct you to the Slido link. You don't need to download any software. It'll automatically pop up on your phone's browser. Do go ahead and provide with us your name and your email. That'll ensure that you do have if you do have a question, we can put a name, face, and a way to contact with you if I'm not able to answer your question during this webinar. So the interactive interface looks like this, and this will be a complement along with the PowerPoint that we're doing. You see, you can type your question in there on the screen, and then right there, what we see is a red lasso, more or less. Go ahead and end up hitting ask, type in your question, and it gets submitted. You then have a secondary option of either allowing for yourself to be named or to ask your question anonymously. Some questions you may not want everyone to know who you are, and that's fine. But again, if it's a question that requires follow-up, I will have to have your name in order to follow up with you. And then also, once you get your question asked in, go ahead and hit send, and then your question pops up. An example is seen there. Is the GTX 345 an ADS-B receiver as well? The answer to that question is yes. A little bit more. You can also, if you see a question that someone's asked and that question is also a question that's burning for you, go ahead and just like I interface there, simulated, hit the thumbs up, and that'll help us know that that question has heightened priority and that we should go ahead and make answering that question a focus. Additionally, you see the stack that is up there in the top corner. Go ahead and press that stack, and that'll show you a number of the interactives, which are more or less the handouts that I have available for you. That's going to be a link to things like our Garmin YouTube page, which is a free way of getting information about Garmin products, as well as some free training. Also, we have links there for Garmin, Fly Garmin for database questions, database management. We also have a link here in the that is for the training classes that we have provided, and also some warranty information, among other things. The interactive that we show there on screen, of course, is not this event, but we just use that as an example. Again, we do prefer that if you have questions, you pose those in the Slido interface, interactive interface. But if that doesn't seem to work for you and you want to just go with something that's tried and true that you feel comfortable doing, then go ahead and send us an email at the link that is posed there on screen. We do want you to also know that for those of you who have Garmin products, please don't neglect the magical black envelope that comes with those products, because it entitles you to free training. I believe it was in 2022, we, as Garmin, gave away about $1 million in free training, but not all of that got utilized because people did not know that there were free promotion codes inside that black envelope. And unfortunately, we believe some of those free codes got thrown in the trash. So don't let that be you. If you have a black envelope, go ahead and go to our Fly Garmin site, as we see here, enter your promotion code in where it says code, kindly click redeem, and then it'll go ahead and allow you to obtain your free training. We're going to go ahead and put the Slido interactive QR code up on screen again, because get ready, get ready, get ready. We have our very first no fault, no fail interactive question. And that question is, the black envelope that comes inside the box with every LRU is important because A, it contains access codes for free training. B, it really is magical. C, it's not important at all. And I'll allow you guys just a few seconds. I won't belabor you, but I'll allow a little bit of time for you guys to just test run the interactive. I'm going to go ahead and advance this time. I see that about 15 of you have responded. Good job. It contains access codes for free training. So that's what's important about that magical black envelope that does come with all of our products. So please don't throw it in the waste bin. A little bit more about training that we have available. We can tailor our training to you. You can come here at our facility here in Olathe. We also make available training to you, our dealers out in the field. And perhaps you also would like to pursue some of our interactive online training. Well, if that's you, you can go ahead and just click from our DRC, the training tab at the top, click training guides, and then you'll see a page which appears like so on screen. And our example is coming from the 2022 dealer training catalog. We hit the download, and then something like so pops up. This is, of course, is our most recent dealer training catalog, and my colleague Jason is on screen actually doing maintenance and probably in the moment recording a training video. Our dealer training catalog does come out twice a year, and you see right now we're covering from September 2023 until August 2024. Inside that dealer training catalog, training opportunities are broken down into both the maintenance training classes, that is what I am doing myself at the moment, and also the pilot training classes. We've, most of the training, the bulk of it would be instructor-led, and you can see down here in the very bottom, the maintenance classes, different denominations and varieties that are available to you. And then over here on the right, you see instructor-led training of the pilot variety. Up at the very top, you see self-study, and that includes the YouTube page, as well as our Garmin Aviation Dealer Academy and other opportunities. Regarding Dealer Training Academy, we're very proud of it. For our dealers, we make some very quick, fast, efficient ways of doing training. You get to the quick and the dirty, the short and the clean as to what you need. You don't, when we cut to the chase as far as all the other fluff. A lot of times those videos are no more than 5 minutes. We're very proud of them, and they cover a host of maintenance topics. If you wanted to provide obtain access to the Dealer Training Academy, you can go do so by requesting a SharePoint Microsoft access. And again, our email, which is on the screen, aviation.training@garmin.com. We have someone standing by who can help you with access. Regarding the Garmin YouTube page, a host of things there, and this is what an example of what you would see if you were go and try to get training on the Garmin YouTube page. But without further ado, let me go ahead and give you another Slido interactive question, and then we'll go ahead and move into our GFC600H presentation. True or false? The Aviation Training Catalog shows all upcoming training opportunities available, and the Dealer Training Academy provides free, quick, effective training for technicians. I'll advance. That is true. Good job. And without further ado, let's go ahead and march into the details of our Garmin Flight Controls 600 Hotel Part 27 interactive presentation. Currently on the AML for the GFC600H, we have Airbus AS350, those varieties that you see on screen, and also the Bell 505. What you might not be familiar with is the acronym, the DHFCS. That stands for Digital Helicopter Flight Control. And this is going to be analogous to the AFCS that you're used to in the fixed wing variety. This digital flight controls, helicopter flight controls, is going to provide things like attitude hold, force feedback, and coupled flight to flight director modes. It's also certified as a complement to the G500H. That would be either the TXI or the original legacy, and also as a complement to the G1000H. What you would see on screen in the Garmin GDU is truncated over there on the far left. And you see this is actually one full screen, but we've broken it down in our manuals to differentiate between the flight director command bars and also the various HFCS enunciations that you would also see. Moving on to the other screen to talk a little bit more about attitude hold. This is the default base mode for the autopilot GFC600H. It requires no input for the pilot. It's an automatic default, and it's going to be allow for assistance in pitch and roll, and alternatively also in heading. While activated, it's also going to provide those smooth hand-flown maneuvers. It utilizes attitude heading reference sensor data to stabilize the aircraft and hold a reference attitude. It is, of course, what we call the base level mode, and above it are other modes that are not considered by default, which we refer to as upper modes as far as this GFC autopilot goes. System is engaged by fault, but also depending on your speed, you may automatically be engaged into what we refer to as ground speed hold. Get ready, get ready, get ready. We have another Slido interactive. I apologize, we do not. I don't see the laser? Oh, my apologies for that. Let me see. Believe that may be because of the Zoom interface. I'm going to go ahead and move on then. Moving on to another subtopic, that being of limit queuing, abbreviated as LMTQ. This is going to assist the pilot by giving a tactile feedback. So this is the idea that if a pilot is flying, he would have a tactile feedback into the cyclic to let him know that there's a danger, him or her know that there's a danger of overflying the helicopter. This tactile feedback is going to be generated by the servos to give opposing unsafe control response back to the pilot. This is going to be as a guard against excessive pitch attitudes, excessive row attitudes, approaching the velocity never to exceed, VNE, and also as a guard against excessive G loading. It is active upon power up, but it can be disabled by holding down the flight controls disconnect switch for a period of 10 seconds. Moving on now to our interactive question. And if you haven't already joined, you can do so by flashing that QR code seen over there on the very far left. Which of the following are associated with limit queuing? Would that be trick flying, aerial exhibition, maintaining safe attitude within the flight envelope, tactile feedback opposing excessive control movement? I'm going to go ahead and advance in the interest of time to cover all the information I can. And we see that two answer choices are, of course, correct. The tactile feedback opposing excessive control movement, and also maintaining safe attitude within the flight envelope of the helicopter. Moving on now to talk about force trim. Force trim is basically a spring force detent that's going to hold those flight controls in a desired attitude. Think of this as being controlled to make sure that the helicopter doesn't bounce around needlessly. So this is a helping hand, more or less. But in the case of having a governing control to give a helping hand, it may be possible that the pilot may want to disengage just temporarily, or at least minimize the helping hand of force trim in order to do a maneuver. Can that be done, Mr. Christian? Yes, it definitely can, with the force trim release FTR button, which is going to result in control forces being increased the farther the aircraft deviates from the reference attitude. So if you don't end up pressing down those force trim release buttons, the more you try to deviate from the detent in which force trim has placed you, you're going to get more limits on your control surfaces. But force trim release will allow you to temporarily disengage, or at least minimize, the governing control of the force trim helping hand. Alternatively to the force trim release button, we also have buttons known as the beep trim switches, which can also provide that same temporary minimized disengagement. Moving on now to talk about speed protection. We talked about ground speed protection. Well, in addition to that, that ground speed protection has two varieties, that of max speed and also that of low speed, and also additionally providing some low G protection available on the Bell 505 exclusively. Level mode. Now, this is one that I like because this is reminiscent of a disorientation recovery feature, which I encountered when I worked in the fighter jet community. Well, it would be a boon, a huge plus to have such a feature on a helicopter. And that's what we have here. So imagine being in a unrecoverable or how hard to come out of flight difficulty. Pressing the level button is going to actually allow that helicopter to return to straight and level flying. So where is that level button located? We have it lassoed there on the front of the GMC, the Garmin mode controller. As you can see, I've actually made that image a little bit bigger there at the top. But I do want to encourage you to read the RFMS, which is the Rotary Flight Manual Supplement, which is complement to the AFMS, in order to get the real full understanding as to how to properly use that level mode button. Moving on now to talk about the flight director. This is going to offer pilot selectable higher level modes. Remember, we were talking about the base level mode being attitude. Well, what are those upper modes that the autopilot has available? Well, they appear here on screen. Indicated airspeed hold, altitude capture and hold, vertical speed hold, and these beep trim vertical flight director interfacing are available through these selections here. We also have available for you heading select and nav select, and that nav is going to provide some GPS SBAS, satellite-based augmentation system interfacing, as well as VOR, localizer, and glide slope. Important to note here that GFC600H does not support coupled en route to VNAV. Moving on, Slido interactive question, true or false? As a flight director, navigation modes GPS SBAS of the GFC600H will support coupled en route VNAV. Is this true or false? A lot of answers came up very quickly, so I'm going to go ahead and advance. False. Good job, guys. You are listening and paying attention. Let's move on now to talk what say ye about yaw control. Now, yaw control is considered an option in our Garmin flight controls autopilots. That's true for fixed wing. That's also true for the rotor ring community. Yaw is an option. So automatically it provides benefits in both cruise and in hover. And in cruise, the yaw control provides yaw dampening. And in hover, yaw axis maintains the aircraft in the proper heading. It's going to allow for very smooth hovering. So you might then ask yourself, well, we're talking a little bit there, Mr. Christian Garrett, about the relationship and the similarities between the GFC600 fixed wing and the GFC600H for rotorcraft. So what are some of the differences? Well, some of the differences I will go ahead and point out as I introduce these LRUs to you. We have the GMC Garmin Mode Controller 600H seen there on screen. It's a little bit different, its appearance from the fixed wing variety. Down there towards the very left bottom, we have the GFC Garmin Force Servo 83. It's bigger in that it's far more robust and a whole lot beefier than the servos that we see in our cable-driven flight controls for the fixed wing community. And then we see a G500 screen, the TXI variety there at the top right. And then we see a GSU75, which is going to be providing some of that external attitude, heading, and reference information. the GFC600H is going to require one of two external AHRS interfaces, that being either the GSU75 seen there or the GRS79H. Another big difference is that there's internal AHRS board inside the GFC600H, GMC605H, but these servos are going to require communication with both the internal AHRS in the GMC and the external AHRS from the GSU75 or the GRS79. GMC 605's got different modes than the fixed wing. Also, it has invis capability for night vision goggles. We don't have that capability in our fixed wing variety. We only have that in rotorcraft. There's dual AHRS that's required. This means GMC 605 internal AHRS board is going to be secondary, but primary is going to be one of those two external AHRS sources, being the GSU75 or the GRS79. Both of those AHRS, the GSU and the GRS, are going to require interface to a GMU44. This means that you're going to have more than one magnetometer on your helicopter. Also, as a prerequisite for the GSU75H, you got to have G500H EFIS already on board. This can be the legacy, so you can have the GDU 620, or you can also have the TXI. You will be required to have those beefy GFS 83 force trim servos. And another big difference is CAN bus routing in the 600H. It's got a dual run of CAN bus running. So it's not just one simple CAN bus route or CAN bus path of high and low. It is two. So there's dual redundancy in the GFC 600H that you don't see in the fixed wing variety. So a little bit more about the differences. The GMs, which is which? Which do you think is the GMC fixed wing, and which do you think is the GMC for the rotorcraft? Well, the one with the green characters is kind of telling you that it's got NVG or NVIS capability. So the one at the top would apply to the rotorcraft community. That is the GMC 605H. Down at the bottom, you have the GMC 605 fixed wing, and the biggest difference in the number of green lights on the side, and also a difference in the number of modes and buttons available at the very bottom. Biggest standout difference, fixed wing variety has VNAV, shown by that VNV button on the very bottom, but you don't see a VNAV button in the rotorcraft variety. Moving on, more about the GMC 605, provides NVIS-friendly modes and status annunciation, provides flight director computations for those upper modes above the default, which is attitude hold, and provides AFCS, automatic flight controls commands, to those servos, those beefy servos. Seen there, taken from our documentation, is where you can see the LED color code. That's got 3 different colors. Green is going to mean everything's good. Red, yellow is going to mean that there was something unexpected, but not a hard fail. And then you're going to have red, which is mean, hey, you're DOA, more or less. You've got a real super hard fail. No puns intended there. And then you can also see the various modes for pitch and roll as where they would appear on the interface, as well as the CAS messaging that would be available to you. A little bit about the internal attitude board. This is going to provide one of 2 required AHRS inputs to those servos, but also on board, it's going to have its own internal rate monitor. So this means it's going to be very smart. It's going to be paying attention to the authority, but not just how hard you moved, in one direction, but the quality of how far that moved. Do you want that response to be quick? Do you want the flight controls to drive faster? Things of that sort. So it's got a whole lot of quality of movement monitoring in place. So when a pilot gives a command, it's going to also be looking to see, was that command actually properly sent to these servos, and did those servos properly respond back? That's also another benefit in having the dual redundancy. This internal attitude board is also going to utilize some of the same attitude aiding sources that we've seen in our primary AHARS sensors. So nothing new here. GPS, MapMX, RS-232, and air data EFIS that's going to be sent over the A-Rank 429. So that RS is recommended serial 232, and that A-Rank is Aerospace Radio Incorporated 429. Additionally, some of that attitude aiding information is going to be coming from the magnetometer by way of recommended serial 485. Moving on now to talk about those beefy force servos. Each one of those servos connects in parallel. And I do have a handy graphic taken from our schematic to show you what that parallel CAN bus interface looks like in just a few more slides. But these servos are going to connect in parallel to each other, and there's going to be two separate CAN bus buses of wiring. These servos are also going to interface by way of control rods, not driven by cable interfacing. And these servos are going to provide a service of actually establishing where the neutral trim position is. Think of that as being the rest for the flight controls. Moving so far into a resting position, and then anything more than that is considered a drive on the flight controls. These servos are also going to be what's responsible for providing what is that force feedback to the pilot. We talked about in limit queuing. We talked about in force trim. There being some sort of responsivity or honeypotting that gets transmitted or felt back on the flight controls to the pilot. These servos are going to be what provide that response back on the controls to the pilot. We'd like to think of these servos as being self-governing, and in that respect, they themselves can be thought of as autopilots in that respect. Inside these servos, they also have a dual monitoring of their own, in that they have dual processors that are monitoring the output shaft torque, speed, and also are there to ensure that there's no exceedance beyond limits. So they're very smart. They're not just taking response or taking inputs and following commands. They're also being real smart to say, hey, I got a command to move in a certain way, but given the attitude of the helicopter, is it safe to move that way? And then they make a determination as to whether or not yes or not they will. A little bit more about the force trim servos. Garmin force trim servos in both the fixed wing variety and the helo variety are brushless DC motors. This means that they don't have shear pins. And that's good news that in the event that a pilot experiences a unresponsive or what appears to be a somewhat locked up flight control maneuver, he or she can use force to overdrive and still fly that helicopter in what they determine to be the safe, necessary flight maneuvering that need be had. In cases where servos are using shear pins, pushing over then makes the flight control do your bidding, but then your aircraft is not as responsive as it need be. Brushless servos don't have that. We have fail passive engagement. It takes about 20 pounds of force to overcome the kickback of these servos, but once that 20 pounds is overcome, no more than 5 pounds of force is then needed to move the flight controls accordingly. Another something about Garmin servos is this is a carryover from our fixed wing community. We have grounding pins which establish the servo's axis assignment. So the way that we define that a servo is on the pitch axis is we actually strap a certain pin to ground, and that determines this servo is a pitch servo. We have a different assignment, but similar by ground strapping to establish roll and also yaw. Servos run application software which is going to be appropriate to their particular axis. And also important to note that you can't change the strapping once calibration and configuration have already done. That'll end up spelling disaster for you as far as automatic flight controls goes. And actually, in fact, the automatic flight controls will not engage if you manipulate the strapping after in the aftermath of configuration and calibration. A little bit more about our servos. We have two different varieties. We have the dash 00 or 00, and we also have the dash 11. The dash 11 would be the smarter DC clutchless, variety that we spoke of earlier. The simplified solenoid engagement clutch would apply only to the yaw axis servo controls. And you might ask why that is, and I believe it's because the default for the GFC600H is for pitch and roll axes to be standard. Yaw is considered an option. So if one were to have a disconnect that would be unfavorable in the yaw, you end up overpowering the yaw, and then you're just back to your standard default of having pitch and roll control. So it's a way of doing a fail-safe, I would believe. At least that's my presumption. The yaw servo, it's seen there on screen. It's the more simple variety. And this is, of course, one of my favorite things in the world. I love exploded views. And here that I see next over to the left, that would be the servo, which will be applicable to the pitch and the roll axis. So you see there's more hardware that applies to that one, more washers and things of that sort. And giving a close-up as we zoom in, we see these curious things which I have lassoed here in blue. These would be the shear fuses, and you see that there is a 1-2 seen there at the top of that one lassoed. That corresponds to the dash part number for that shear fuse. That shear fuse is going to be what is needed to overcome that 20 pounds of force to allow that pilot, he or she, to overcome in the event of flight controls appearing to be jammed and still needing to maintain an input for safety of flight. So where do those shear fuses appear? Well, you see the hardware in two places there. You see over there to the left where the shear fuse is getting inserted, and I'm showing with red arrows where it actually interfaces. Over here on the right, you see the shear fuse in place with a safety device which is necessary for actually setting the null position for the servos, more or less assigning rigging. We got another Slido interactive question. So choose all that apply to the Garmin Force Servo 83. They are connected in parallel on the CAN bus. There are two varieties of dash part numbers that are available. They are brushless DC motors allowing passive fail for the pilot to overpower. And grounding pins establish assignment, and altering this strapping after the system configuration and calibration will result in system fault and AFCS being inopt. Choose all that apply. I've been told that we have some questions that you guys have, and I do have a interface there at the end. I'm going to try to make allowance for answering some of your questions as we round out the end of the presentation. Going to go ahead and move forward. Didn't mean to be tricky, but wanted to go ahead and reward you if you remember some familiarity there. Yes, all of these reasons do apply to the Garmin Force servos. Good job. A little bit more about the dual AHRS interfacing seen inside our mode controller for the GMC605H. This would be the internal, and also there's going to be the need of external AHRS interfacing from either the GSU75H or the GRS79H by required or by requisite of the STC. And my colleague, Chris Hendricks, likes to say that this marriage between the interfacing of the internal and the external is a match made in heaven. And I hope that he's not trying to make a pun with Valentine's Day being right around the corner. A little bit now to be said about how those servos actually interface. We had talked about the CAN bus 1 and the CAN bus 2 lines for interfacing. And as you will see over here on the right, we have the yaw servo at the top, we have the roll servo just beneath it, and we also have the pitch servo there at the very bottom. You will see also the assignment of those pins and those connectors. Let's use the Papa 831-P for the pitch servo as our example. You see it has the CAN 1 high and low and the CAN 1 term resistor. And beneath it on pins 5, 6, and 17, it has the CAN high 2, CAN low 2, and the CAN 2 termination resistor. So if you would follow the snaking of that daisy chain, you'll see that the CAN 2 from the pitch interfaces into the CAN 2 of the roll, and then out of the roll interfaces into the yaw, and then out of the yaw, that CAN 2 comes over curiously to the AHRS, either the GSU75 or the GRS79, and then there is a splice to take that to complete the loop up to the GMC605H. Alternatively, CAN bus 1, high, low, and CAN termination resistor out of the GMC on CAN 1, snakes and daisy chains in and out of all three servos as well. So what would that look like if we take away the schematic and superimpose our pictures of those LRUs that we introduced to you earlier? Yaw at the top, roll, pitch, a GSU75, and a GMC 605. Well, CAN bus 1 bus segment would look like what we see here, and CAN bus 2 segment would look like what we see here. This is what we refer to as the option 1 bus type interfacing in our STC. What then might be option 2? Well, I'm glad you asked. It's the simplified version that does not have yaw as an option. It would appear as so. Nothing different there other than the fact that the yaw servo has been removed. A quick word there about the CAN bus wiring. CAN bus wiring that we use in our fixed wing is the same CAN bus wiring that we're advocating for in the rotor variety. You can always tell CAN bus part number because it's got that telltale 120 in the part number itself. 120 for CAN bus wiring is indicative of the required impedance that CAN bus must have. Two suppliers we have there, Carlisle and Gigaflag. Moving on, we have a real-world troubleshooting example now that applies to an AS350 Bravo 2 variety. The discrepancy was that the GMC600H would pass pre-flight tests, but would fail for limit queuing and for flight controls. And occasionally it would also fail in yaw, exhibiting also messages on the GMC and also on the GDU 620 Legacy variety showing limit queuing message and FCS fail messages. So what symptoms did this problem have? Well, it had 4 symptoms. Number 1, system operates normally with yaw disconnected, with only 2 axes engaged. Well, that's kind of curious and problematic. Let's hear a little bit more. Symptom number 2, no change after removal and replacement of the yaw servo, reloading of the software, and recalibrating. It's also kind of strange. Number 3, fails pre-flight tests. The failed pre-flight test status would toggle intermittently between servo status page, showing either passed sometimes and also alternatively no data at other times. And this would be for all servos. And that's really, really interesting. And then number 4, there was an inconsistent CAN bus impedance measurement noted that was not showing a measurement of 60 ohms between CAN high and CAN low. Ring, 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 the dinner bell just rang out. That should be your telltale clue to go looking in a hunting to see if you don't have enough or have too many CAN bus termination resistors. Equivalents, the impedance equivalence of 2 120 ohms resistances in parallel is going to be 60 ohms. So if you have the right number of CAN bus termination resistors and you measure from high to low, you should expect to see 60 ohms. If you don't, you got problems. If you've got 120 ohms, then you're missing a term resistor. And if you have something curious like, say, 40 ohms, you got one too many at least termination resistors. So beware also the note there at the bottom, and we'll talk a little bit more about CAN bus terminations at the GFC600H as applies to this scenario. But in this case, the real world troubleshooting example, we were doing some hunting around with the multimeter, and we noticed that there was no there was a CAN bus impedance that was not correct between pins 5 and 6 on the yaw. We only had a reading of 120 ohms. So somewhere along that CAN bus 2, we're missing a termination resistor. We also then went hunting, and it was pretty easy, I assume, to pull out the GFC605. So they looked at the back of that and saw no CAN bus termination on CAN 2. So then that got the noodle, the mind turning over ideas of where would we then expect to see other CAN bus termination resistors in the system. We don't have one at the GMC, so maybe we have one at the pitch servo because the documentation says to terminate there. Well, maintainers went looking and did not see a CAN bus termination resistor on the CAN 2 line at the pitch. So things are getting really interesting because when we looked at the yaw servo CAN 2, it showed that there was a 120 ohm resistor, but now where is that 120 ohm resistor? Well, documentation did state that it was in the interest of saving on time and routing CAN bus wiring through the Airbus, that it was possible to alternatively terminate at the GSU-75H. And therein lies the pickle of how this became a troubleshooting scenario. Termination in our documentation for the GSU-75H is highlighted on screen and says CAN bus termination must be spliced to CAN high when terminating the GSU-75 at the end of the bus. This is different from other GFC600 HLRUs, which require termination to be spliced to CAN low. So it could be that the maintainer was mindful of what was our usual convention for terminating by splicing a drive CAN low to the term resistor and not being mindful of the new requirement for terminating at the GSU-75, which is splice CAN high slave to the term resistor. So that yaw servo was reading 120 ohms for a runaway termination that was CAN low to term resistor and not CAN high to term resistor at the GSU-75. Very interesting. This came up last summer. So the fix on that was to overcome the splicing at the GSU-75, slave in a jumper cable and then connect with the proper CAN term resistor at the pitch servo, and then voila, everything was ops check good. True or false, Slido interactive question. If terminating the CAN bus at the GFC600H, the CAN term pin will not splice from the more common CAN low. This is true. You will not terminate from the CAN low. With the case of the GSU75, you will splice from CAN high. Moving on to talk about other issues regarding splicing. In the case of attitude aiding information, you must splice from your navigator to the GMC605 and then have a splice also going to your GDU. In this case, we're talking about the G500, either the Legacy or the TXI. So we see there GPS number 1 navigator, attitude aiding, GPS number 2, attitude aiding, and time mark for those MapMX related information. Going to the next slide, what does that look like? We show the splice, and notice it curiously says to a Garmin GDU. Want you guys to be on guard against splicing to different Garmin GDUs from the same source. That information there is intended to be a coupled package of MapMX and time mark to the same GDU. Same source, same destination, similar grouping on the destination. We have seen troubleshooting scenarios where that information was spliced, and it posed some interesting challenges for those related. Seen differently here, we show the GDU 700 and the GFC 600, and I'm showing you how time mark information is always going to be pertaining to either a TXI or a G1000's Garmin interface EFIS. Time mark you will not see in the case of a G3X, because the way that LRU is made, GPS information is bundled within the internal circuitry and does not need outside GPS helping hand. But in the case of the TXI, the G500, and other G1000 systems, MapMX and time mark information has to come from a LRU other than the GDU that's reporting it. Let's go ahead and give you just a few more information here, and then I'll round out very closely to the end. Select all that apply. GPS attitude aiding must include MapMX RS-232, time mark signals from the same source. It's okay to split the MapMX and the time mark and to send these signals to different LRUs, different GDUs, and MapMX and time mark interfacing applies to the interfacing of a GTN and either a G500 or a similar G1000 system. Give just a little bit of time for interfacing there, for answering that question. Going to move on. See that more than 10. Yes. The attitude aiding relates to MapMX RS-232 and time mark signals. They must come from the same source. They must be coupled together to go to the same destination. And this applies to G500, either TXI or Legacy, and other relatable G1000 systems from Garmin. In the case of the rigging, we want to go ahead and encourage that you follow method A and not method B, as method A requires a hydraulic mule, and method B requires basically what amounts to a lockout tagout in order to establish that null for your rigging pins. We also want to go ahead and give you similar guidance with the GFC600H that you see in our fixed wing. Pitch and roll offsets calibrations must be done at the same time. Magnetometer calibration also must be done at the same time. And servos require magnetic heading data in order to pass PFT. Similarly, for the GFC600H TXI, the STC requires all these that you see bulletized on screen. Notably, it's going to require rotorcraft enablement, applies only to VFR, which means daytime and nighttime. And if you're using a standby, you can't use a G5, and you can't have any interfacing to your TXI. It is pre-required for the GFC600H to have the G500H installed. And also, if you cannot use the Adahars variety, you cannot use the Adahars GDUs. They are not approved. They are actually have a different box interfacing on the back. We use them primarily in, say, a Daer TBM for cabin pressure pressurization information. They are not part of the STC here in the helo community. Also with the G1000H STC, the big tidbit of information here is make sure you're loading those software loader images in the right order. So G1000H NXI first, and then software loader image for the autopilot GFC600H. If you were going to use TXI for your helicopter, this would apply, of course, for VFR only. You've heard us say that at least 3 other times in this PowerPoint presentation. The STC does not approve the relocation of the engine tachometers. The STC is not the approval authority for NVIS operations, so it's incumbent upon those installers to get that NVIS certification should they choose to make that a feature for the install. Base GI275s and GI275 Adahars, that being the -00 and the -30, are also available for the helo, and also the NVIS base and Adahars are also available. Notice, if you know anything about our GI275, you do not see any of the Plus AP models on this table here. And that's because the Plus AP are reserved for interfacing the third-party autopilots. No third-party autopilots are approved with this STC for the GFC600H. So what do you get for the TXI double-lot base model? You get the bulletized information there, MFD and EIS display capability. And in the Adahars, you get standalone ADI. Just giving you the rundown on what comes in Plus AP, but again, the Plus AP is not available for this autopilot interfacing. And I'm showing you in red what is approved for the rotorcraft autopilot interfacing. A little bit more, if you got a GI275, you can use it for MFD standby ADI. But if you have, as a standby ADI restrictions, these all apply right here. So GI275, you can use it as an MFD or standby ADI, but you have restrictions on how to use that GI275 if you're interfacing with a G500 TXI, a G500 Legacy, or similarly a G1000 interfacing EFIS. Notice you gotta have it, that GI275, you can only use it as a standby ADI only, and all those additional MFD pages, they got to be configured to off. Similarly, the type certificate data sheet is going to specify in the note there at the bottom that the standby airspeed indicator must have markings that match what is seen in the type certificate, the POH, and the RFM. Last, I believe it's our last question here. Commonly use the GI27, the use of the GI275 in a helicopter, which would apply? It commonly comes with restricted use as a standby ADI only and with no possible use for MFD pages. B, only the 2- part numbers are available for the rotorcraft. C, VFR only use is available. And D, STC does not approve relocation of the tachometers, nor does it provide NVIS certification. Going to advance. Yes, of course, all those do apply. Want to just go ahead and let you guys know that rotorcraft eligibility, this is your guidance in making sure you do things right in the right way. We'll encourage you to go to that. And here we have the questions there at the end. Let's see, Joshua Salas, is there a remote switch option for the level mode? No, sir, I do not believe, haven't read anything about that. So all I know of is that level mode switch is there squarely on the GMC 605H. Good question, though. That might be something to follow on to the engineers. Yeah, that's a good follow on. Thank you, Mr. Jason. Let's see, Robert McSheehy. Who would be a good point of contact to get the GFC600 in the BE 1900 Charlie? I am willing to bring the 1900 to help with this process. Oh, that's really good. Actually, best place for you to go, our outward facing Garmin site, we actually have a way for you to click on a hypertext link and actually do just what you're doing. Make yourself available for testing, certification, augmenting the STC, things of that sort. So if you don't already know how to navigate, go ahead and follow those helpful links that I've got, Garmin.com in the drop down at the stack, and be directed to do just what you're asking. Good question. Michael Height, does this training offer apply if the Garmin equipment I'm installing is an experimental amateur build? Absolutely not, sir. This is STC. STC pretty much has a lot of restrictions on what's available and how you got to do it. You got to do it their way. Experimental, no, sir, need not apply.
Training packets. You're playing us with the question.
Oh, as far as training information goes, yes, we do have G3X information as training available. And also we have a big presence at Oshkosh, the EAA Air Venture. We do a number of things for the experimental light sport community out that way. So if that's the context in which you're giving your question, yes, sir, we have a lot of training, G3X light sport experimental related. Anonymous, is there any special inspection required when replacing a sheared tab? I'm actually going to have to look because I would think that debris would want to be a concern. I haven't heard anything about there being about there being anything other than a clean break. But anytime there is a break of a material, you would probably want to do an inspection, make sure there isn't any bits of debris there. I will go ahead and follow up. Ooh, this person is anonymous. So I'm not going to have any way of getting back to you, but I will do my due diligence to go ahead and look and ask that question back to our engineers. I will leave this link available for at least 24 more hours, and I'll put a response back to you. Do my best to get back to you, even though you haven't given me your name. And with that, guys, I'm going to have to end it there. Unfortunately, if you have any additional questions, you can contact us at the link that is seen there, aviation.support@garmin.com, and also alternatively our phone number. And thank you for your time. Appreciate being here with the Alaska Air Carriers, being a part of your training. It was a blessing to me to kind of reconnect back to my old community. Thanks a lot. You guys have a great day.
Thank you so much, Christian. We appreciate you being here. Okay, folks, up next we have Tony Toth with the FAA to present service difficulty reports. Tony?